So here is a problem right up here. And you can see what they did right here is the original problem, maybe we can write this down. The original problem for this one was x minus 1 on the top. And on the bottom, it was 2x squared minus x minus 1. So that's what they wrote up here. And then over here, you can see they already did the factored form because we already know there's some things that we can get from the factored form and there's some things we can get from the original form. Do you guys want to color code your notes? Would that be helpful maybe? Yeah. All right, so if you look at the factored form, the first thing they did is you can see that they canceled this factor and this factor. And then they said, all right, those factors that cancel must make the whole. Right? So one of the things that you can get from the factored form of the equation is you can find the wholes. And the wholes come from factors that cancel. So one of the things you can find from the factored form is the whole. And the wholes come from factors that cancel. Yep, so the whole has an x coordinate of positive 1. And how do we find the y coordinate of the whole?
Oh, you plug it in.
Yeah, you plug the 1 in, but you don't plug it into the original equation. You plug it into the leftover factors, okay? So if these canceled out, that means that we have a 1 left over on the top of the problem, because anything that cancels out to make a 1. So we have 1 on the top, and on the bottom we have 2x plus 1.
Isn't that 1 3?
Yep, and so if I want to find my y coordinate, then I need to take the 1 and plug it in for x. So 1 over 2 times 1 is 2, and 2 plus 1 is 3. So that gives you a y coordinate of 1/3. So there's the whole at 1/3. Okay. Don't completely scribble domain out, but we are not going to worry about domain for today. Domain is another thing you can get from the factored form. So over here, we're going to go ahead and put domain for the last bullet because we are not going to worry about it today. So you can find it from the factored form, we're just not going to do it. Okay. Next, another thing that we can find from the factored form is the vertical asymptote. So you look at the factor that is left over, and you look at what we usually say the opposite of that factor, but this factor is kind of weird because it says 2x plus 1. So we have to think about what would happen if we took the factor 2x plus 1 and we made it equal 0. So if you take the factor 2x plus 1 and you make it equal 0, this is for us to find our vertical asymptote. What is the first thing we would do to solve for x? We would minus the 1 over. So I would say 2x equals negative 1. And then what would we do next? We would divide by 2. And so x would equal negative 1/2. And so that's where the vertical asymptote of x equals negative 1/2, that's where it came from. So you take whatever factor is left over on the bottom, and the factors left over on the bottom become the vertical asymptotes. Okay? So over here on our notes, we're going to add that one of the things you can find from factored form is the vertical asymptote. And those are factors left on the bottom. Now for us, we usually look at factors on the top. We look at things on the top to see what the x-intercept is, because you find the x-intercept by taking the fraction and making the fraction equal 0. That's how you make a y-coordinate equal 0, is you make the top of the fraction equal 0. This is not going to give us any x-intercepts because the number that's on the top of this is actually a whole. And so for x-intercepts, they said none. So we're going to look at x-intercepts more in the next example because this one doesn't give us a whole lot. All right, and then we've got things that we can find from the original equation, and one of those is the horizontal asymptote. So how does this tell me that my horizontal asymptote is 0, y equals 0? Anyone know why it tells me? You might have to look at your notes from the video.
Oh, because the degree.
The degree?
Bottom,
yeah.
The denominator is bigger than the one.
Yes. So if you look at the top, the exponent for x is just a 1. So on the top we have an exponent of 1, on the bottom we have an exponent of 2. And if you look at your video notes say that anytime the degree on the bottom is bigger than the degree on the top, your horizontal asymptote is just 0. Not another number, always just 0. Okay? All right, so we got that. So one of the things we can find from the original equation is the horizontal asymptote. And to find the horizontal asymptote, we are looking at the degree of the numerator and the degree of the denominator, because we have to compare them. We have to compare how big the numbers are. So degree of numerator, degree of denominator. And there were 3 situations, if you look at your video notes, we had 3 situations. One was this situation, where the degree of the numerator is smaller than the degree of the denominator, and that's when you have y equals 0. What happens if the degree of the numerator is exactly the same as the degree of the denominator? It's the leading coefficients, right? Y equals whatever the numbers happen to be. What if the degree of the numerator is bigger than the degree of the denominator?
It's none.
It's no horizontal, but what is instead? Slant asymptote. So here we're going to say another thing that you can find from the original equation is if you have a slant asymptote or an oblique asymptote. It's just a fancy way of saying your asymptote is diagonal instead of horizontal or vertical. You've got a diagonal one. And this is not something we're going to find in Math 3. That's something that you're going to find in pre-calculus. Okay. And then what's the last thing that we need to find? The y-intercept. And that's another thing that you can find from the original form. So if you look, what they did is they ignored anything that had an x in it. Why did they ignore anything that had an x in it for the y-intercept? Yeah, because when you find a y-intercept, you have 0 for all your x's, and they basically all go away. So the only thing you care about when you find a y-intercept is you care about the numbers that did not have an x with them, because they're the only things that are going to be left over anyway. So for the y-intercept, and I should have made this colored. There we go. So it matches. So the y-intercept, if you look at the top, we have a -1, and if you look at the bottom, we have a -1. And so what they said is -1 divided by -1 equals a y-intercept of 1. So here, the last thing we can get from the original equation is the y-intercept. And you look at the numbers without an x. So we only looked at the numbers that did not have an x with them. And that's what helped us find the y-intercept. All right, let's go ahead and look at the next example. So if you guys can see this one, it was x squared plus 7x minus 8. And they factored it so that they said, oh, and they factored it incorrectly. Go back to this one, and for your original problem, take the plus 7 and scribble it out and put a minus there. I'll go ahead and zoom in on this one. Okay, so that should have said minus there. And this is a plus 2. I don't know if you can tell. Goodness gracious, there's all sorts of mistakes on this one. We might have to fix some mistakes as we do this problem, okay? Because it has to be a plus 2 right there for the factors to work. Okay, so on the top they said x squared minus 7x minus 8 should give you factors of x minus 8, x plus 1. Do you guys agree with that? X minus 8, x plus 1. At the bottom, x squared minus 3x plus 2 should give you factors of x minus 2 and x minus 1. Do you agree with that? Okay, so I'm going to ignore domain for now. So what are some of the things that we were able to find from the factored form? Yeah, they said there's no holes. How did they say there's no holes? Yeah, nothing canceled, right? So over here I'm going to write nothing canceled. Okay. So then you can see that there are 2 vertical asymptotes. So one of the vertical asymptotes is x equals 2, and the other vertical asymptote is x equals 1. So the reason that we knew that those were vertical asymptotes is because vertical asymptotes are factors that are left over on the bottom. And in this case, nothing canceled, and so every factor was a factor on the bottom that was left over, because nothing canceled. All right, where did they get those x-intercepts from? So they said x-intercept is 8 and negative 1. Where did they get those from? They got them from the top. So x-intercepts, you can add this to your bullets. Another thing we can find from the factored form is x-intercepts. And those are factors that are left on the top. So x-intercepts are factors that are left over on the top.
So when we're graphing these, are on the notes last night, we only did one of the lines, and we kind of estimated the top line. Are these all for one line?
It depends. So when we did the video, we knew where the dotted lines were.
Yeah.
And then we had enough information where we could tell where one of the curves was, but we couldn't tell where the other one was. Sometimes the problems, if you draw your asymptotes, it's really obvious where all your curves are, and sometimes it's not. So it kind of depends on the problem.
Okay.
Yeah. Okay. So we've got that. So if we look back at our notes, then that means our x-intercepts are going to come from that factor up here. So there's that one, and then here's the other one. All right. And then if you look over at the original form, we can see 2 things from the original form. So we're going to look at what the horizontal asymptotes are, and we're going to look at what the y-intercept is. So they looked at this problem, and do we agree with them that the horizontal asymptote should be y equals 1? Is that a correct answer, y equals 1?
Yeah.
Yeah. So how do we know that that's correct? Yeah, so we have an x squared on the top and an x squared on the bottom, so that means our degree is the same. And then that tells us we should look at the leading coefficient. And the leading coefficient is just the number that comes in front of the x squared. So this is 1x squared divided by 1x squared, and that makes sense for a y value where y equals 1. That's a valid answer. And then last, we want to look at the y-intercept, and the y-intercept is what you get when the numbers are without an x. So if we look over here, the numbers without an x are these numbers on the end. And do we agree with them that it should be positive 4? No, we should disagree with them. What should it be? Negative 4. So I'm going to go in and just fix that. Should have been negative 4. So 0, y equals negative 4 is what we should have got. Okay, so the other characteristics that we are not going to look for today, but these are the ones that are found from the graph. The range, that is something that we are not going to find from the equation. The increasing and decreasing intervals, we are not going to find from the equation. Those are going to be from the graph. And then any max or min, in calculus, you can find it from the equation, but we are not in calculus, so we are going to find it from the graph. We will do these, but for the next couple days, we're going to work just with the stuff we can find from the equation, and then we're going to start finding stuff from graphs. Okay, so let's go ahead and do another one together. So we're going to look at this one on the bottom and see how we do finding all that stuff that we just did. So the original equation that we're going to look at, we are going to do, let me think here. We're going to do y equals x squared minus 4 divided by x squared plus 3x plus 2. So what should we do first? Factor. So anyone know how to factor the top? All right, and how about the bottom?
X plus 2, x plus 1.
Mm-hmm. And we're not going to worry about domain for right now. So what else can we find? Or what can we find from the factored form? We can find holes. Does this graph have a hole?
Yes.
Yes. Okay, so can someone at Quinzia's table tell me what the x-coordinate of the hole is? -2. Someone at Colin's table, can you help me find the y-coordinate? Wait, what would you make x? What would the x be? So you're finding the y-coordinate, and to ever find a y-coordinate, you plug in the x-coordinate. So what x do we want to plug in? -2. Yeah. So, and where do we plug the -2 in? Yeah, so we're going to say the whole's, I didn't do a very good job of writing it. I wrote it up here. So we write down what's left over, and then we plug the x into what's left over. Yeah, perfect. Okay, so if we look over here, the stuff that's left over is x minus 2 over x plus 1, and that is where we were plugging the negative 2 in. So we're going to have negative 2 minus 2 divided by negative 2 plus 1. So someone at Courtney's table, can you guys tell us what the y-coordinate ends up being? The bottom is negative 1. The top is negative 2 minus 2? Negative 4? Mm-hmm. So what's negative 4 divided by negative 1? 4. Mm-hmm. Okay, so there's the whole. Alright, and then someone at Dacia's table, can you guys tell me, you can pick either a vertical asymptote or an Xintercept. Could be anyone at your table.
The Xintercept is 2, 0.
Okay, so she is looking at the factor remaining on the top. And she's looking at the opposite of that, so that tells her that the Xintercept is positive 2. So 2, 0. Alright, someone at Ricky's table, can you tell me the vertical asymptote? Mm-hmm. Yeah, so we're going to say x equals negative 1, and that came from this being left over on the bottom. And then, does anyone at Pedro's table know about the horizontal asymptote? Y equals 1, how'd you get that? Oh, it should have been positive 12.
I don't know how you could reduce that.
You factored this one out.
I did. Thank you.
All right, so x squared over x squared, the degree is 2 and 2, so it was the same. And so Pedro said that it should be y equals 1 because you're looking at the leading coefficients. 1 over 1 is 1. All right, and then somebody along the back wall, can you guys tell me how we get the y-intercept? So you can look at your notes. We said y-intercept. We're looking at the numbers without an x. Somewhere along the back wall. So what are the numbers that don't have an x attached to them? Yeah, so negative 4 on the top and 2 on the bottom. And so what is the y-intercept? Negative 2. So 0 for x, negative 2 for y. Zero for x, negative 2 for y. Okay, so those are all the things we're going to find. Does that make sense?